Okay, welcome again, and we are in the second part of our video on the project management. And in the previous video, we have seen how we can construct a network diagram for activity on arc and activity on node. So we ended at this point where we have constructed a network diagram for activity on node for our given example. Now, we are going to see how we can compute the early time and the late time, and also how we can compute the floats of different activities in our projects. Okay, now let's see. We have this activity on node diagram network, and this activity on node here, we have placed some boxes or a table with a single row and two column, and in the left cell we are going to feed with the early time, and in the right side of this box we are going to feed with the late time. That means in filling the information for early time for each activities, we are going to apply the method called the forward method. And in determining the late time, we are going to use the backward method, and these informations will be filled using this formula, as the formula for the left hand side of the box will be the earliest time, and on the right hand side will be the late time. Now let's start filling the earliest time, and we are going to start at this node 1. So in critical path method, we set the initial or the early start time to 0. Okay, so setting this one, this becomes the earliest start time for these three activities. So let's go one activity after another. So since activity 1 start immediately at 0 time, then the early finish time of this activity will be the early start time of the previous node plus the duration of that activity. That means we are taking 0 plus 2, we are going to have the early finish time of activity A, which is 2. Also for activity B, its early finish time will be the early start time of this activity at node 1 plus duration, which is 4, and we are going to have 4. And the early start time of activity C will be 0 plus 3, which is 3 here. Okay, so after having this early finish time of activity A, B, and C, now these early finish times at this node for other activities emerging after completion of this activity, the earliest start time for the next activity. So once this is finished, we start another activities. So the 2 here is the early finish time of activity A, but it is early start time of activity D. So now let's move to node 5, which is the event after completion of for activity D and E. So you can see here the event at node 5 will start after completion of activity D and activity E. So the earliest finish time, okay, of these two activities will be the maximum value between the earliest finish time of activity D and earliest finish time of activity E. So let's move this one at the left hand side here and see. So we are going to pick the maximum value between the earliest finish time of activity D and E. So the early finish time of activity D is the earliest start time of this activity at node 2, which is 2, plus the duration, which is 3. And the earliest finish time of this activity, okay, is the earliest start time of this activity at node 3, which is 4, plus 6, and we get 10. So we pick the maximum, and the maximum there is 10. Okay, and after having that one, now we move to the next node, which is node 6. And node 6 also, 2 arrows are coming in, so the earliest finish time of these two activities at node 6 will be the maximum value also between the earliest finish time of activity G and the earliest finish time of activity F. So you compute that, you will find that the earliest finish time of activity G is 17 and the earliest finish time of activity F is 8. So the maximum value here is 17 and we are done with the computation of the earliest time. So let me go back again. I said that this is the earliest start time for this activity and this 2 is the earliest finish time of activity 2. But this earliest earliest finish time of activity 2 is the earliest start time for activity D. Okay? And this 4 is the earliest finish time of activity B, but it is the earliest start time of activity E. Okay, so this one is the earliest finish time of these two activity, but it is the earliest start time of activity G. So 3 also is the earliest start time of activity F. So we are done with the earliest time computation. Now we need to use the backward method to compute for the latest time. Okay, the latest time, now we are going to apply the backward method. So the backward method, we start from the last node here, okay, and the latest finish time of these two activities here, we just pick this earliest finish time and we substitute it to this right hand box and become the latest finish time. So we pick that one, and the latest finish time for these two activities becomes equal or is equal to early finish time of these two activities. Now, after having this late finish time for activity G and F, now we need to go back to find the late start time. So this 17 is the late finish time. So the late start time of activity G, okay, is the difference between the late finish time minus the duration, and that we can see at this node we are going to have 10, and the late start time of activity F is the difference between the late finish time of this activity at this node minus duration. So at node 4 we are going to have 12 as the late start time for this activity. But this late start time of activity G is the late finish time of these two activity D and E. So to compute for late start time for activity D, we just take the late finish time of this activity minus duration, which is 1. We are going to have 9 there, and the late start time of activity E, we take the late finish time of this activity E at this node, which is 10 minus duration, and we are going to have the informations. So we are going to have 4 here, we are going to have 9 there. So this is the late start time of this activity D, E, and F. Now we need to compute the late start time for these 3 activities because they start from the same node, so they will share the late start time at node 1. Okay, remember we have 3 activities. Now this late start time is the late finish time. So to compute for the late start time, okay, we will pick the minimum late start time between these 3 activities A, B, and C. So the minimum value among these 3 is 0. So the late start time for 3 activities A, B, and C is going to be 0. So we have managed to compute the earliest time and the late start time for the 3 activities A, B, C, D, E, and F together with G. So now we have to wind up our discussion on this part B because we are also required to compute for the floats. Okay, now let's move to the next slide and see how we can compute the floats. Now we have this table, and basically you need to prepare this kind of table which will help you in computing this total floats, the free floats, and the independent float. Okay, now let's consider the previous network diagram, which we computed. It's a early time and the late time. So in this network diagram here, you can see that we have already informations for early time and late time at this point. Okay, so we can just feed the information for the earliest time and the late time. Remember, I said that the earliest start time for activity A, we say is 0, okay, but the earliest finish time is 2. And this earliest finish time is the earliest start time of the other node, which is node D. Okay, now for simplicity, let's fill this information. Okay, this is the earliest finish time. We pick this earliest finish time from this node. Remember, for activity A, the earliest finish time is 2. For activity B, which is 1, 3, okay, the earliest finish time is 4. For activity C, which is 1, 4, the earliest finish time is 3. And for activity 2, 5, and 3, 5, 2, 5, and 3, 5, 2, 5, the earliest finish time for 2, 5, you see it's 3. We didn't take 10 because this 10 here represent the final completion time for all the activities, which is the maximum value for this event to begin. So when we fill the information for the earliest finish time in the table, now we need each activities to determine its earliest finish time. So for activity D, its earliest finish time is the earliest start time, which is 2 plus 1, and this is 3. And this 3 to 5, the earliest start time was 4, so we add with 6, we get 10. So the finish time also for 4 to 6 is here, is 3 plus this 5, we get 8. And the earliest finish time for activity 5, 6 is 10 plus this 10 plus 7, which is 17. So we are done with filling the information for the earliest time. Now we have also the other information in the right hand side of the box in red, representing the late finish time. Okay, so let's go quickly on how we can get these informations here. Starting from the last node, you can see that the late finish time for this activity G and F is 17. So activity G and F, that is 5 to 6, 4 to 6, their late finish time is 17 because they share the common endpoint. So you can see here. Also activity 3 to 5, 2 to 5, okay, both of them, they share the same node, and the late finish time of these two activity is 10. So you can see 3 to 5, 2 to 5, their late finish time is what? Is 10. Coming to node, these three nodes now, okay, which is node 1, 4, 1, 3, 1, 2. So 1, 2, the late finish time is 9, okay, which is here. 1, 3, the late finish time is 4, and 1, 4, the late finish time is 12, which is this one. So that is how you can fill the information for the early finish time and for the late finish time. So we are done with that information. Now, the other informations, which is the early start time and the late start time, you can get from this table, or you can use the following formula. As I said, when we were filling this one, we said that this information here is the early finish time of activity A, but it is the early start time of activity D. Okay, so in order to avoid confusion, just take this information as the early finish time and the late finish time. So for early start time and the late start time, just use the following formula for simplicity. So for early start time, we say that the early start time can be computed by taking the early finish time, okay, minus duration. And we have the early finish time, and we have this duration D. So taking early finish time 2 minus 2, you have 0. 4 minus 4, you are going to have 0. 3 minus 3, 0. 3 minus 1, you will have those information, and just click that, and then you'll have all the informations concerned about the early start of the projects for different activities. And the late start of the activities basically also use just this formula, that is the late finish minus duration. So late finish is here, the duration is there. So subtracting each late finish with the respective duration, you'll have the late start, and we are going to have that information there. And the next column is the total float. How can we compute the total float? The total float is the difference between the late finish and the early finish, or the late start and the early start. So the difference between late start and the early start gives you the total float, or the difference between the late finish and the early finish gives you the total float. So computing that, because we have those information, late finish and the early finish. So computing, you'll end up with this column here of information. Now we are done with the total float. Now we need information for these two other kind of floats. We have free floats and the independent floats, but in order to compute this one, you need these two informations, the head event slack and the tail event slack. How can we determine or get the head event slack? So let's go and check again. So remember, we have this structure here as a network activity for activity A, okay? As part of the network activity for part A, we have the activity part A with the node 1 and node 2. So this is the beginning of the activities, and this is the end of activity A. So the beginning of activity, we call it the tail, and the end of the activity, we call it the head. So the head event slack is basically the difference between the late finish and the early finish. So taking that difference for the head event, okay, you have the head event slack. So this is for node for activity A. Also, you can compute that for other activities. Okay, for instance, for activity B, you can see we have activity B with head node. This is the tail. So the head node is 4 as the late finish, and the 4 as the early finish. So the difference between this late finish and the early finish give you the head event slack. So doing that, or following that order in other nodes, okay, you can see the for instance, you can go to the event D. Okay, this head event here becomes the tail for event D. So the G point in the network we constructed, or we are using, the G point will be the head event. So the difference between the late finish and the early finish will be 10 minus 10, which is 0. Now, after knowing how you can determine this head event slack, then compute, you are going to end up with this column here, and now you will be in a position to compute for the free float, and the free float is the difference between the total float and the head event slack. So we have the head event slack and the total float. So taking the difference between this one and that one, you're going to have this column information. So the last part is the independent float, but we need to compute for the tail event slack. So the tail event slack, consider this part here. I explained earlier that the activity basically have two nodes. The beginning of this node is called the tail, and the end of the activity is called the head event. So the difference between the previous, the head event slack, okay, is that we use the information at the head of the activity. Now we are going to use the information at the tail of the activity. So the tail of this activity A is at this node 1, which is 0 minus 0, we are going to have 0. For the other tails, like tail for activity B is here. We have the same tail, so we are going to have 0 minus 0 again, which is 0. So proceed, this one, remember, is going to be the tail for activity. With this, the next activity here was D, and here is E. So this is going to be the tail for activity E, and this is going to be the tail for activity D. Also, the activity C is going to be the tail for activity F. Okay, so proceed computing in that way and fill the information. You will end up with this column informations. So after tail event slack computed, now you are also in a position to compute the independent float, and the independent float is the difference between the free float and the tail event slack. So computing that difference, you are going to end up with this column here. Okay, after completion of calculating the early time, late time, and the total float together with other informations, I would like to insist one critical informations obtained from the total floats. So the total float give us the informations on the activity delay time. So we have some activities with non-zero and other activities with zero coefficient. Activities with non-zero coefficients, this we term them as non-critical activities, and activities with zero coefficients are called critical activities. So critical activities, basically they have to be considered right away at the scheduled time without a delay. That's why you can see the total floats for critical activities is 0. But for non-critical activities, you can delay for sometimes, as illustrated or demonstrated by the total float. Okay, so the critical activities basically need special attention of the project manager, because any delay in the critical activity cause a delay in the project duration. Okay, now you can represent that critical activity in a network diagram, or you can show it, because we have seen that activity 1, 3 is a critical activity, and also we have activity 3, 5, and activity 5, 6. These activities are critical activities, and critical activities, they form a critical path. Okay, critical path is the longest path in the network with the longest duration time. Okay, so these critical activities here, 1, 3, 3, 5, 5, 6, they form a critical path. So now if you need any kind of delay in your activity, you better go through this other non-critical activity, 1, 2, 2, 5, 1, 4, and 4, 6, depending on the total floats. Okay, thank you for watching, and then let's meet in the next part of this video, where we are going to see how we can present these results in a format that is clear and understandable to all parties involved in the project.